Good morning, good afternoon, or good evening. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2025, Paper 2, Variant 2. In this video, we will quickly go through all the questions and I'll be highlighting the important points you need to focus on, and the points are the main concepts you need for the exam. Are the concepts where students most of the time they lose marks and they have misconceptions. Let's study together, let's improve together. For this question, simply we need to state what is accuracy. So this is how you can state accuracy. But you have to pay attention to one point. You have to say that how close, because you are defining the accuracy. So this is very important one. You have to say how close the measured value is. Measured value is to the actual value of the quantity. For the second part, we need to calculate the density of the material. So simply you have to use formula and you will get this answer. As in this case, data, you can see this data has 3SF. This one also has 3SF. So in the final answer, you can use 3SF. So 3SF are also acceptable. As in the question, they have given you this value. That's the reason we have rounded off to this one. But you can also write down, first of all, you answer in 3SF, then you can round off to 2SF to match this given answer. So here we need to calculate percentage uncertainty. So you can see all the steps are written here for you. Simply you need to look at these steps. If you have question, you can ask me in comments. So this is the main point you need to understand. So this is here, delta V by V. In this case, because this is L cube, so if we have, for example, y, this is equal to x to the power of n. So in this case, fractional uncertainty of y, this has to be equal to the power time the fractional uncertainty of x. So in this case, volume V, this is equal to L cube. So that's the reason we have cube in front of this. And the final answer, very important one. So we got answer here, this is 3.6. Final answer means the percentage uncertainty or absolute uncertainty at AS level. You have to state up to 1 SF, only 1 SF. So it should be stated up to 1 SF. So in this case, first of all, we have determined density ranges, material A, material B, and in this case, the densities, the ranges are overlapping. So as ranges, they overlap, so it means they can be made of the same material. Very important point. So here is the key concept. Overlapping, it means they can be made of same material, so they can have the same density. Principle of moments. So how we define principle of moments? Very common question. So you need to be able to define principle of moments, how to state. So you have to say for a body in rotational equilibrium. If you simply say for a body in equilibrium, that is also acceptable. And you need to say sum of clockwise moments about a point, very important one. If you simply say sum of clockwise moments is equal to sum of counterclockwise moments, that is not complete answer. So you have to say sum of clockwise moments is equal to sum of counterclockwise moments about the same point, or you can say about a point. So better way to define is sum of clockwise moments about a point is equal to sum of counterclockwise moments about the same point. You cannot say two different points. Same point is very important one. And this question is also based on moment. So in this case, simply you need to understand sum of moments about A is equal to 0. So we have taken clockwise moment, anti-clockwise moment, then by equating we have found answer that is equal to 2.1. As the least number of SF in the data is 2SF, so the final answer also should have 2SF. For this part we need to calculate upthrust. So in this case, upthrust is equal to weight of the beam and the force from the beam. Weight is acting down and the force from the beam is also acting down. So that's the reason upthrust. So this is equal to weight plus force from the beam. Then simply equating we can find out the answer. As in this case, this final answer has 2SF because the least number of SF in the given data are also 2SF. So that's the reason you have to use 2SF. So for this one, simply we need to use upthrust equation. So here we have upthrust. This is how we calculate upthrust. Very important one. Most of the time students, they have half understanding of this one, upthrust. So upthrust is equal to rho. This is density of the fluid. Very important one. Density of the fluid time value of G time volume of fluid displaced. This V, this is volume of fluid. Volume of fluid displaced. So this is how you need to understand upthrust. And then just plug in values. You can find out value of Y. So this is the Y. So this is the volume. We are talking about this much volume of the fluid. Means this much volume of the fluid will be displaced. This much. So very important one. So you have to be clear about this. So this is how you can find out. So V is volume displaced is equal to cross-sectional area times A. Actually this is a cylinder, so you can imagine this is cylinder like this. So this is cylinder. So this is cross-sectional area and we are talking about this much height because this much volume of water fluid will be displaced. So this is over Y. And for this part we need to sketch a graph between Y and depth and the distance from this point, and this is a linear relationship. So when x is equal to 0, there is some value of here. So when this one A is equal to 0, I mean distance, this person is standing at this point. At this point there is still some depth. So that's the reason it has to start from here. It should not start from the origin. When it is here, beam is here. So beam has some force on the cylinder. So cylinder will be inside the water, means it has certain value of depth. So it must have Y intercept. If you're more curious about this one, we can also derive the equation for this graph. So this will be the equation. So you can also see in this equation, this is Y intercept and this one is the gradient. But you don't need equation, simply you need to understand how it is changing. But you can derive this one based on principle of moments. We can derive this. For this part, we need to calculate acceleration. So acceleration in this case will be constant. So we can simply use SWOT equation. So we can use this equation. So we can plug in values and we will be able to get this value of acceleration. In the next part, we need to calculate gain in kinetic energy. So we have values of V's and we have the mass we can plug in. So this is our final answer. And final answer should have 2SF because the least number of SF, you can see we have 2SF, 2SF, 2SF. So it also should have 2SF. So simple use of formula in this case. For this one, we need to define force. So this is common question. You need to understand how to define force. So when we define force, force is equal to rate of change of momentum. So delta P over delta T. So this is the resultant force. So this is how you need to define force, rate of change of momentum. And for the second part, we need to calculate the force. And very important one thing, maybe you will find the answer, most of you will find the answer, but you need to understand we are calculating average resultant force. So in this case, resultant force is not has one value, resultant force is changing. If you look at this graph, we have momentum here and we have time here. So how the force is changing? Force in this case means the resultant force we are talking about. This is equal to delta P over delta T, means the gradient of this one. So as the gradient is decreasing, it means resultant force on truck is decreasing. So gradient is decreasing, as you can see from here, so it means resultant force is also decreasing. So then plug in values at 2 points when t is equal to 0. So we have value of momentum that is equal to 21. So here this value is 21, and when t is equal to 15 seconds, so here, so if we draw the line, you will see that momentum, if we draw this line like this, so this is 2.5. So that's the reason we have 2.5 here. We got this negative answer, negative. So negative is telling us direction of force is opposite to direction of velocity. So that's the reason momentum is decreasing. So in this case, body is speed is decreasing. So simply I can say in this case speed is decreasing because the force is opposite to direction of motion. So imagine that if object is, in this case, velocity is positive, so it's moving this way, so the force is this way, is opposite. So force is in the opposite direction. Okay, for this part, an identical truck has the same initial momentum, means initial momentum is the same as truck R. Truck S experience a constant force equal to force F in B2, mean in the last part the value of the force we have calculated, the same force it experience S. So that is the constant force it experiences all the time. State and explain whether truck S will take more, less or same amount of time to come to rest as truck R. So simply we need to understand F is equal to delta P over delta T. For these two trucks, change in momentum is the same. Change in momentum is the same, but in the last part we have calculated average force only from 0 to 15 seconds. But if we calculate average force from 0 to 21 seconds, 23 seconds, actually this will be 23 seconds. So average force, so we can say F for R, it will be lower than the one we have calculated in part B. In the second part, average force will be lower. So it means that the average force on S is greater than average force on R. So you have to look at this question, try to understand the logic. So in this case, average force on S is smaller than average resultant force on R. So what does it mean? It means that if this force is greater, how about the time taken? It has to be smaller. So this is the main concept you need to understand. If this is clear to you, so now we can write down the answer. So this is how you can write down the answer. You can say momentum is the same. So average force on S is greater, so the time taken will be smaller. So it will come to rest in shorter time. So next question is about waves. So here, this is a typical question about formation of stationary waves. So you have to be clear how stationary waves are formed. Explain how the stationary wave is formed, including how nodes are formed and how antinodes is formed. So I have written these points. So when the phase difference, you can see 0, so that has to be phase difference is equal to 0. So it means amplitude will be maximum. So this one has to be antinode. And when phase difference is 180 degrees, so amplitude will be 0. So mean the amplitudes will cancel out if they have the same amplitude. So that point we will say is node. And for stationary wave to be formed, waves must be traveling in opposite direction. So important one, stationary waves are formed when waves are traveling in opposite directions. So that is an incident and reflected. What is meaning of this one? They are simply telling us these two waves are moving in opposite directions. So here we need to calculate wavelength. So simply just use the formula and you can find out wavelength. But you have to be clear, microwaves, they are electromagnetic waves, and the speed in air, the v in air is about equal to v in vacuum. So this number you need to understand. What is the value of the speed? So that is 3.00 times 10 to 8. Then you can plug in. So you have the frequency, you can find out lambda. The next part, we need to find out the distance between point P and Q. So if you go back, you can find out P and Q. So in the question it is given to us P and Q. So you have to read here what P is representing, what Q is representing. Stationary wave is formed between the device and the sheet. So in this case, between P and Q. So for P and Q, here informations are given here. So at this point it is given to us, at point P, receiver detects a maximum amplitude. So amplitude is maximum. So what does it mean? This means that here is antinode. So this one is antinode. The first time a minimum amplitude is detected when the receiver is at point Q. So it means Q is node. So simply now we have one node, one antinode. So what is the distance between node and antinode? So let me draw here one simple stationary wave. So this is one loop is representing. This one is one loop. So this point is antinode and this point is node. So this is node. So what is distance between node and antinode? This is lambda by 4. So if you have understanding of this one, distance is equal to lambda by 4, we can find out value of distance. So this is how you can find out value of distance. Again, our answer must have 2 SF in this case. Now for this question, state and explain whether the distance QR is greater than, less than, or the same as distance PQ. So you can look at this explanation. So in this case, one very important point you have to understand is that the frequency is unchanged. And if the medium is also unchanged, so frequency unchanged, so first thing you can notice from here, frequency is unchanged. The second thing you need to understand, the speed of the wave. Speed of the wave, it depends on medium. Same type of waves, they have different speeds in different media. And also it depends on type of wave. Different type of waves in the same medium, they have different speed. So in this case, medium is the same. Type of wave is also the same. So type of the wave is the same, medium is the same, so speed is also same. So if V is the same, F is the same, lambda, this is also the same. So this is same, this is same, so lambda also stays same. So here is the key concept for you. Let me clear. I have explained you this key concept, but still you can read this one for your better understanding. For this question, we need to calculate lambda, but time we can read from here, and then we can find out value of lambda. Lambda is equal to V times T. T has to be the time period. Why time period? Because lambda means one cycle. So this is the distance traveled by wave in one time period. So this has to be time period. 1 lambda, time taken is 1 period. Then plug in values, you can find the answer. So this is a nice question. This is about Doppler effect. So you have to understand in this case, period of the trace increases. So if period of the wave is increasing, so what is happening to the frequency? Means the observed frequency. This one is decreasing. Then it is given continuously decreasing. So it means frequency is also decreasing continuously. So we need to understand Doppler effect. As frequency is decreasing, it means source is moving away. So you can also deduce this one, source moving away. Source is moving away in this case. So in this case, let me rewrite this one. So F naught is equal to Fs, and we have here V, this is the speed of the wave, and we divide it by speed of the wave. Speed of the wave is not changing. So here we have speed of the source. So in this case, as this is increasing, this is constant, this is constant, this is constant. So what is happening to Vs? Vs has to increase. So source is moving away and the speed is increasing. Means source is moving away and source is accelerating. So as this will keep on decreasing, so let me write on. So this one will keep on decreasing like this, and this one will keep on increasing. So this will keep on decreasing. So you can see this arrow is getting shorter and this one should be getting longer. So this is what is happening. In the exam, in the answer, what answer you need to write down? So this is the answer. This point simply you need to write down. If you will write on this one, you will get 2 marks. Moving away is important point. Moving away and at increasing speed. So here we need to calculate potential difference. Simply plug in values and you can find the potential difference. So again here simply you need to use the formula, plug in values, you will get the answer. And here we need to calculate the number density of charge carriers in a wire. Number density. So number density you need to understand is equal to number of charge carriers per unit volume. And volume is equal to A times L, means cross-sectional area, times length of the wires. Length of the wire means wire is we are treating as a cylinder in this case. So value of N is given, A is given to us, L is given. So we can find out the volume. So volume is equal to AL. We have volume, we have N, just divide and you will get the answer. Next one, calculate average drift speed. So you need to simply use the transport equation. So this is, and then plug in values, be careful with the units, and you will get this final answer. You can also use this approach as well. You can also do in this way. So this is a typical question as well. So you have to be clear about this. So in this case, state and explain how the resistance of wire Q compares with the resistance of wire P. It has the same volume as a wire P. A different copper wire has the same volume as wire P but non-uniform radius as shown in figure 6.2. So in this case you can see resistance, this is equal to rho. They are made of the same material, so rho is the same, L divided by A. So in this case volume is the same, they have the same volume. So we can say volume of wire Q and P is the same. So they have the same volume. So we can simply say A times L. So if A go down, L will go up. So now you can see from here, if L go up, resistance will increase. If A go down, resistance will also increase. So it means resistance in this case will be increasing. So these points I have written here in a very systematic way. You can look at this one, but the main idea I have explained to you. Now for this part of the question, we need to sketch a graph now. The graph we need to sketch is between average drift speed and distance from X. When distance is equal to 0, charge carriers, they still have drift speed. I mean charge carriers are not at rest. But as the distance is increasing, area is decreasing. So we can say in this case drift speed, this is equal to I over NQA. As area is decreasing, cross-sectional area means we are talking about this cross-sectional area. As this is decreasing, so the V should increase. So they are inversely proportional. So the shape of the graph, it has to be somewhat like this. So this is how you need to sketch the graph. If you want to draw this one in a more accurate way, so it will look like this. Now the last question. For the last question, this is just straightforward one. Simply you need to understand mass number has to be same. charge has to be the same, means mass number is conserved, charge is also conserved. So you can figure out. So if you have done this one, all these steps are written here for you. So this is your final answer. Now here we need to calculate the speed of nucleus R after the decay. So in this case, you can see this is daughter nucleus and this is parent nucleus, and here we have alpha particle as the initial momentum. So let me explain you the main idea first of all. So simply you can imagine first of all, so we have nucleus. So this one is parent nucleus. So we have said this is nucleus Q. So this is nucleus Q. This is nucleus Q. Its initial momentum is equal to 0. Then it decays into daughter nucleus. This is daughter nucleus we have, that is R, and we have alpha particle. After decay, alpha particle will move in one direction, so it has certain momentum. To conserve momentum, R has to move in the opposite direction. So the momentum of R nucleus has to be equal to momentum of alpha but in opposite direction. And how do we calculate momentum? Momentum is equal to m times v, the product of mass and velocity. Now simply use conservation of momentum and you will be able to find the answer. So here I have written this one in detail, so you can look at this calculation. So this is mass of alpha particle and this is mass of R nucleus. Speed of alpha particle we have, so we can calculate momentum of alpha particle. So this is momentum of alpha particle, and momentum of alpha particle is equal in magnitude to momentum of R nucleus but in opposite direction. So negative simply means that these two vectors, they are in the opposite directions. And then by equating the magnitudes, we can find out value of R. So this is momentum of nucleus R, so we can find out the speed of nucleus R. And for the last part, we need to answer theory quantities, state theory quantities that are conserved during the decay. So in any decay, momentum has to be conserved, charge has to be conserved, nucleon number means the mass number has to be conserved, neutron number has to be conserved, proton number has to be conserved, lepton number has to be conserved, and mass energy on both sides have to be conserved. So these are the things you have to write down in your answer. So you can write down any three of them, any three quantities you can write down. So that's all for this paper. We have done this one in about 30 minutes. So I have gone through this one quickly. I hope this gives you better understanding. And if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. And if you're looking for more resources, please join Patreon. And on Patreon, I have uploaded a lot of resources, especially for Cambridge A-level physics, AS and A2. And if you go through those resources, especially most frequently exam questions and revision notes, those notes and most frequently exam questions will help you to improve your understanding of physics and ultimately your grades in A-level physics. And also I post every day one important question, typical type of question from A-level physics or from other resources. And also I always upload some important concepts that are challenging or tricky concepts. So join Patreon, you will see a lot of resources and those resources can be very helpful. That's all for this video. See you in next video.